So please welcome Sean.
Oh, thank you very much. Hi, my name is Sean. I'm a cloud technical lead for a place called Center Group. They're the company in Australia that manages and runs the Westfields. I've been doing DevOps for about a little over 5 years now at a couple other places, places like IAG, Gumtree, Tyro, and the NBN. Sorry for that bit, wasn't my fault. So I'm here today to talk about securing your AWS Identity Management pipeline with PyTest. So the main driver for this was, how can I keep my cloud safe without driving my fellow developers completely mad? AWS IAM is one of those fun things where it's easy to get right, easy to get wrong, and very difficult to get right. It's the identity and access management system for the Amazon cloud. Pretty much everything that you're doing in Amazon cloud is going to rely on AWS IAM permissions at some point. This is everything from your VMs running the workloads on them. If you're running like Lambda, even some of the newer Kubernetes constructs all rely on AWS IAM to run. This can be particularly difficult when it comes to your user management. All of your users using AWS via either service accounts or their physical IAM users are going to be using these policies in order to do everything. So you always really want to make sure that these are really secure, but it's not easy. How do we end up with IAM problems? The granular permissions in AWS are really easy to target very specific things. These very specific things that you're trying to target are typically resources in AWS. For the most part, it's particularly easy to target a few things. What happens is you end up going to production, and you've missed some permissions in a lower level. It can be really difficult to make sure that, it can be really difficult to make sure that you're targeting the right things and you don't have an over accessible permissions. When it comes to giving these permissions to developers, as someone in a DevOps role, you're typically the gatekeeper for these kinds of things. This usually means that you're the one reviewing PR, you're the one trying to make sure that everything is going through smoothly, and that interaction with your developers generally means that either you are overwhelmed at scale, approving permissions that shouldn't really be there, or that your developers are having difficulty figuring out the right permissions for their objects. Taking a look at an example of the kind of documentation that you get for this. The documentation when I first started this project was completely awful and scattershot. There were bits and pieces about how IAM worked everywhere. There was a nice aggregation site called Cloudonaut, iam.cloudonaut.io, still kicking around. It had some fairly basic information around how these permissions and what they could target worked, but there was no real programmatic access for any of this. You can see here that now they've kind of given you a little bit more information, at least in the documentation. As an example, if any of you have used the S3 service in AWS, you can do things like create buckets. You can see here that the resource types required for targeting a bucket is a bucket object. You can see down below, this is what a bucket looks like. This basically gives you the conditions for when you're running this action that helps you lock down these in whatever way under the resource types and condition keys there. So you've got developers and you've got automation that really needs to start using this. So you generally tend to start putting objects together. Let's automate all of it. This generally takes place in teams starting to build together stuff like CloudFormation, starting to put together Terraform projects. Those who are new to the cloud journey end up writing, maybe some custom scripting, a lot of stuff in Python. It ends up scaling quite quickly out of your control and can be really difficult to manage, especially for Terraform. For Terraform, there's some options for kicking around, like doing validation. Like there's a project called Terraform Validate, which will let you do basic things like making sure that certain standards are present in Terraform, making sure that certain variables are set. But there's nothing that really lets you dig into the nitty-gritty of how these things should be set up. And then once you're done setting it all up, knock, knock, who's there? It's security. Generally, security comes knocking on your door asking, hey, we want to prevent certain things from happening, or we want to make sure that when people are writing policies that they're adhering to the sort of standards that they set. As a security team new to the cloud, a lot of the troubles that we've had in the past are issues where, a lot of the issues that newer security teams have had in the cloud are things like they're not entirely sure how AWS works, they're not entirely sure how to create these programmatic constructs, and they're not sure how to add this without going completely mad. This is a big issue when it comes to things like breaches. As we saw in the ethical constraints talk before, breaches do happen, and when they do, you really want to limit the amount of stuff that can happen. So let's take a look at what are we looking for in terms of requirements. We're really looking for a flexible testing framework. We're looking for something where we can push the quality left. We want to be able to run those tests in pipelines when developers are creating code, when your DevOps team are writing their Terraform. And ideally, we want a programmatic data for validations. Now, how can I build a programmatic definition for something that's just a bunch of HTML tables? Those of you who've been using Python for a while, there's a hint in the icon. Hands up. Oh, beautiful soup. So we've gone and scraped the AWS documentation. We've gone and scraped out all of those beautiful little definitions we saw in tables, and we've used those to build a skeleton framework that says, hey, when I'm running these actions, these are the kind of conditions you should be looking for. It's not pretty, it's not great, but until AWS kind of gets their stuff together, it's probably the most reasonable thing that we can do. When we start putting these all together, this is what the output looks like. We've got the definition of an AWS action, we've got some metadata around it, we've got what a resource condition looks like, and then the resources that it can target. As we can see here, we've got S3 buckets. Create buckets can target things in a standard AWS ARN. This basically says that, hey, you can lock down this exact action to this exact target. So how do we start putting that together? How do we find a nice flexible framework? Those of you who've been in Python for a while, PyTest. I was really surprised when I found out about this. PyTest supports testing things more than just Python files. There's some custom collectors you can write in PyTest that allow you to basically scrape anything. For those of you who may be the Python person in your team, this can help drive your teammates nuts when you find out that you can run Python against anything that they write. But it really lets you do some nice flexible and modular configuration of Terraform there. And it's easy to write. The nice thing about those PyTest tests is that there's stuff that you can share with the other non-traditional developers in your group. Stuff like I've had security people can understand and write these tests. I've even had some product owners and project managers who can go and reasonably validate, like, hey, these are the kind of tests that we're looking for. These are the kind of tests that we're writing. Let's go and write a PyTest plugin for this. PyTest plugins are fairly simple. They leverage a powerful Python construct in setup tools called an entry point. Entry point says that, hey, whenever I'm running this script, these are the sort of plugin interaction points that you can add. You leverage the Python 1.1 entry point to basically add some hooks into the file collection that says, hey, whenever you're looking for tests, PyTest, you can also call me, give me a list of files, and I'll tell you whether or not these pass muster or not. In this, we use the PyTest collect file function. In your plugin, you overwrite that. You basically say, hey, if the path extension is a Terraform file, we're going to return a HCL file around it. HCL file is just a wrapper around the standard Python class that defines a file type. A standard PyTest class that defines a file type. As part of this HCL file, you're required to yield. This yield basically allows you to do a programmatic set of tests. You yield for each test that you want to run against. The thing that you're yielding is a PyTest item. PyTest items are basically an overload of the built-in PyTest item for running tests against. This basically lets you programmatically define, this is how I want my test to look, and these are the sort of conditions around it. If you're subclassing it, make sure you init and pass in some extra stuff. In this case, we're basically saying, hey, we're going to pass in some additional spec from the parent object. And then we define a few things that help this plugin just look nicer. So run test is the fun thing that runs the tests, and we've got repr failure. Repr failure is a representation of the failure that comes through. This basically says, if we're raising an exception downstream, this is how you make it look nice. This is how you make it presentable in a PyTest format. We've also got report info. Report info is crucial for if you're doing any kind of custom PyTest collection. Report info says when this information comes back, be it pass or fail, what is the metadata around it? This is crucial for stuff like Terraform, because if I just say, hey, S3 violation somewhere, no idea. This basically lets us say, like, hey, in this particular stanza of our Terraform, this is where we're running into the issue. Around this Terraform stuff, the reason that we're targeting Terraform first is that there was very easy support for it out of the base. These patterns are very easily extendable to your other definitions. Stuff like CloudFormation is some pretty standard YAML. But today we'll be demoing the PyHCL. PyHCL is basically a library for parsing the HashiCorp configuration language, version 1. When I first started this project, Terraform 0.11 was in its heyday, with Terraform 0.12 sort of looming in the future. That had been looming in the future for so long that we kind of ignored it. And then, of course, like 2 months ago, Terraform 0.12, that's a new language. Support for that is coming upstream, but it's something we don't deal with yet. This basically gives us simple parsing of Terraform objects into a dictionary. We can use that dictionary when we start scraping these objects for testing to give us a standard report back. So how do we put it together? It's fairly simple. You basically publish your module somewhere, be it if it's an internal repo into Git. If you want to contribute something back to the community, it's a PyTest plugin, pop it onto PyPy, anywhere you want to pop it. In terms of using this locally, all you really have to do as a consumer is install PyTest and install a plugin. This basically means anytime you're running PyTest, that collection will start getting run. Super easy for your developers. One of the big things that we really want to focus on was making sure that there's a smooth developer experience. You just run PyTest. You can see here, this is an action that we're running. It's basically a PyCon, a PyTest that's running against a couple Terraform things that will show back the results. We can see one pass, one failure, and we can see where that failure happens. I'll be going through the code for that in a demo in about a minute. So the requirements, have we hit all of them? We've got a flexible testing framework. We've got something that can run in a CI pipeline, and we've got some programmatic data for validations. We've built that programmatic data, but that's okay. It fits. So what have we learned from all of this? HTML documentation can be workable with Python. The original intention of this was just to help out my team with the Terraform that they were writing. We quickly found that this stuff could be used and extended for quite a few other kind of files. It's very, very powerful and something that I'd really like to see people start using more in the future. So let's take a look at how this stuff is put together. There we go. So we've got our plugin.py. Plugin.py is where the bulk of your plugin configuration and code is going to be. We do a few things in this file here too, and basically get the entire environment set up. We define things like the PyTest collect file, where we go and validate what files we want to test against. We define that HCL file as a subclass from pytest.file. This basically allows us to programmatically present files as objects back to PyTest. On that is a collect action or a function. This basically is where we start looking at our HCL. This is ideally where you want to start validating whether or not those files that you're collecting start having information inside them that you can validate against. It's perfectly fine as a PyTest plugin to scrape and accept a lot more files than you can handle, and then just poke at them, see if they've got something interesting for you to validate against, and if they do, yield a test. Here we've got our IAM policy document. This is where we're yielding that object to give us a Python test. And then down here we've got our actual subclass pytest.item. This gives us a few things like the run test, the repr failure, and the report info. you can see that our run test here, we've built a little validator that can go and validate those IAM statements. The sort of standard for operating with these is that if something goes wrong, you raise an exception. Here, we just run the validator, and if it accepts, then cool, we're going to handle that report info in the repr failure. External exceptions can be a little bit trickier to run and manage. There's a few test cases that I ran into here where testing PyTest with PyTest can run into some recursive issues. When you do get those kind of failures, you'll see those as big stack traces, but that's fine. Then we've got our report failures down below. We can see here that we've got our validation. Our validation for this is fairly simple, as it's a sort of a sample project here. We've got our IAM validator. We've got our little IAM JSON that we built that spec from scraping the HTML. And then we just basically do some simple validation. If it's got a resource that we can validate, we'll dig through it, check out some logic to say, like, hey, does this action have a resource condition that we can validate against? If it doesn't, skip it. Nothing we can really check against. If it does, cool. Warn them with an exception that, hey, we've run into an issue where you could be locking down this permission, but you're not. As part of that, you can run tests in your Python PyTest plugins with just simple stuff like go and validate that your stuff's working. We can take a look at what this looks like on the target level. So as a developer or a DevOps person, there we go. I'm going to be writing a whole bunch of Terraform that basically has these policies built in. This is a very simple one with a resource target that says, hey, allow create bucket against this very specific ARN. This is a perfectly valid one that we expect to pass compared to something like this, where this is a S3 create bucket with star permissions. This is something that we very explicitly don't want to allow. There are some back and forth when it comes to AWS IAM. S3 buckets can have their own policy permissions, so this stuff tends to be a little bit more useful for a little bit more open actions, like EC2 actions. And we'll just quickly pop in and run a quick demo. So as you can see here, we've got our little repo with our 2 Terraform files defined, and we run PyTest. Boom. So we can see that in the closed resources Terraform, we've got 1 pass. In the open resources Terraform, we've got 1 failure. Down here, we can see that metadata information that we populated previously in that PyTest plugin says, hey, under that resource, S3 open bucket policy, we can see that that failure is happening here. And this is the failure that we've got. S3 create bucket, we've specified a resource star, but it actually supports this ARN condition. And so a developer or a DevOps can take a look at this exact failure and say, cool, I've got an issue with S3 open bucket policy. Pop back to my code. Close this useless thing. And there we go. Cool. And that's it for the demo. Any questions? There. Oh, microphone.
So one of the things about detecting this is that you flag a whole bunch of security things and then you have to give it to people and they have to go fix it. Could you programmatically just fix it? Like, that's an open bucket. Yeah, no. Because we have a standard policy of how you should fix that. So just fix it. Don't make me code extra stuff. Yes.
The only problem is that if you programmatically fix it, sometimes you can be catching it too late or too far in the development process. The idea for this is that it should be complementing whatever you're running in your production runtime. We've had setup before where we've got stuff like AWS config rules are a really good way to go and scan resources and programmatically lock them down. But if you're always doing that in production and developers never have to learn this is what a proper IAM policy looks like, then you're relying on your automation to make things good instead of your development practices. So yes, but do both.
Any other questions?
I like when they go.
So in relation to this, you're testing the instructions that will eventually build the environments. Have you investigated any tests to see if anybody's had bad deployment practices and actually put those rules into the wild to solve some problems?
Sorry, can you repeat the question?
Are you actually testing against what's implemented as well?
Oh, about the code that's actually gone out?
Yeah.
Not with this. This would be just as part of a CI pipeline. We did introduce it at a bank that I worked at previously as part of a basic CI system, but it doesn't run against production code, but it will stop stuff from going to production.
No more questions at all?
Awesome. Thank you.
You're all brilliant at AWS Identity? Because I'm not. Thank you. So we want to thank Sean. Enjoy your mug.